Start. In this video, I present my DIY control system. It's very easy to build. You just print out some structural parts and mount 12-volt electronics on them. Then, you can set up all the desired ventilation speeds for your fan, and the humidity and temperature will regulate the rest. You can also add an automatic watering system. If the soil humidity falls below a target level, a small pump will start to pump water. I'll give a complete tutorial on how I assembled the controller and conclude with a list of materials you'll need if you want to build your own controller. When I started, the design was functional. If a cover were placed on the box, the mess would be concealed. However, the solution was not ideal for sharing. So, I cleaned it up and removed any programming. The final design is simple and effective. This is DIY-Tek with Chapter 4.05. Now you will learn how to build the heart of your grow or dry tent. Since this project is multi-layered, I decided to take an unusual approach. I produced this video in a way that it can also be used as a printout. This means you can use it offline, or even just print some single pages of it. All the designs shown can also be downloaded. Hey! My name is Daniel, I am from Germany, and I will be your host. Let's build a controller. This is the structure of this video. First, I will explain the specifications that guided me. Then, I will show you how to build the controller and present a longer video of the system in action. Finally, I will close with a bill of materials. Here you see how a good controller should work. You have a set point, such as a specific temperature. If your tent does not reach that set point, you have a negative delta. The controller calculates and adjusts the output voltage for your heating element accordingly. The nozzle or the printing bed of your 3D printer is controlled in a similar manner, using a PID controller. Good for us, we can simplify the system. Here you see the parts that our system consists of. The tent will be our controlled system. The controller will only start or stop the humidifier and illumination according to our targets. Ventilation will run permanently, but you can set the speed. This is called a bang-bang control. Bang for on and bang for off. This makes the build much easier. This was my concept build. I started with an Arduino system. One had to program it with C++. I also used a CO2 sensor back then. I learned that one is not necessary. Just set up your airflow as much as needed. The first controller I used to control my tent was this one. I added strain reliefs for the external components and fast connectors. I also added a display and keypad for input and status control. A real-time clock was included to keep track of the time. In this model, I still used a CO2 sensor. If you put a cap on the box, it looks clean as well. In the next build, I improved the cable management. The human-machine interface stayed the same. I went all in on DuPont connectors, as they can be easily created at home with the right tools. This build also worked well in my tent. This was my last smart build. I upgraded to an ESP32 microcontroller, which allowed me to move into the cloud and control the tent externally. It also enabled the addition of a camera to supervise the tent from afar. However, I realized that not many people would want to replicate this solution, as cloud access is not really necessary for most setups. Then I decided to have everything on one piece of paper. This was possible due to a new humidity controller I found after my initial research, and because I determined that CO2 control is not necessary. The template can be glued to a board. Then, you drill the holes for the components and just connect them. Very easy. The board can be mounted on the back or side of the tent. It is very cheap to build. Since growing wheat is of interest to many more people compared to growing mushrooms, I decided to make another iteration and create the optimal controller for a cannabis tent. I stuck with the paper layout since everyone can easily print out a DIN A4 paper and glue it to a board. I also use a basic LED power supply. 60 watts is more than enough for everything. Cable canals ensure a proper, clean look, and plugs simplify the connection of external units. These two step-down units allow you to connect and set up the speed of two internal 12V fans, ensuring continuous air movement for optimal growing and drying results. With this unit, you can regulate the exhaust speed. This is important because you can control a lot with the air exchange of the tent. The intake air is passive and HEPA filtered. Then I decided to have everything on one piece of paper. This was possible, due a new humidity controller I did not find in my first research, and because I decided that CO2 control is not necessary. The template can be glued to a board. Then you drill the holes for the components, and just connect them. Very easy. The board can be mounted on the back of the tent or at the side. It is very cheap to build. Then I decided to have everything on one piece of paper. This was possible, due a new humidity controller I did not find in my first research, and because I decided that CO2 control is not necessary. The template can be glued to a board. Then you drill the holes for the components, and just connect them. Very easy. The board can be mounted on the back of the tent or at the side. It is very cheap to build. I added 2 extra constant 12-volt plugs for additional equipment. I used one for a constant fan in front of the humidity sensor and the second one for my auto plant watering system. Behind this cover, there are WAGO connectors, and there is still one extra 12V port free, so you can still enhance this controller any way you like. The lighting system is on purpose not integrated into the controller board. Since it works with higher voltage, it is for safety and convenience reasons best to use just available plug-and-play solutions. Here you see the specifications for my system. You can pause and read them. They are not all-inclusive, but you will see that I reached my goal of high practicality. In this next chapter, I will teach you how to build the controller yourself, step by step. I documented my own assembly, which you can use when you do your build. I also created a wiring diagram that you can follow when you assemble the control unit. This diagram simplifies the documentation down to its basics. Here is an excerpt from the wiring diagram. I created it in a straightforward manner, but it contains all the necessary details. I am providing you with the necessary cable lengths for convenient cable confection. You can find the wiring diagram.pdf via the supplied links. Now we will do the photo assembly, step by step. I will perform the assembly of one complete control unit. You need to print out the template on a 1:1 ratio. You will find it where all my PDFs are. The PDF is CAD created and works flawlessly. Get your wood board. The size does not really matter, but it must be bigger than 360 x 30 x 16 mm. Print out the layout and glue it to the board. This is how I positioned my layout on the board. Make sure that you can also position a wiring duct under your layout. Check the positions of your components. The specs of the boards vary depending on the manufacturer. The rough outline is enough, since you use a spacer for each drilled position. Just mark the correct position for drilling. Drill 0.2,5 mm holes for self-threading M3 screws. Position your power supply. There should be enough space, that you can also use an even bigger one. Mark the drilling positions. Drill the 2 holes. Position the cable duct. Mark the needed positions for drilling. Perform the drilling. Install the cable conduits. Cut the wire ways on the needed positions. Prepare the wiring for the power supply. You also need cable end sleeves. Connect everything. Check if voltage is okay. Please be careful. These are our basic components for the further 12-volt supply. Connect 12V to a WAGO connector 221-2415. It looks like this. Next we will install the step-down components. Humidity, 20 centimeters. Fan 1, 15 centimeters. Fan 2, 10 centimeters. Now you need spacer. I printed them. You can also try washers, wood spacer, etc. Be inventive. What follows is the installation of the corresponding connectors. Fan 1, 15 centimeters. Fan 2, 10 centimeters. The connected cables. The installed connectors. Now I will install the exhaust step-down component. 20 centimeters cable. Use your spacer. Screw it in place. Install the exhaust connector. 25 centimeters cable. Fixate the connector. Install without power, use spacer. 1xxHM452, humidity control. Cable length, 35 centimeters. Install the humidity connector. I use a connection in this way to ensure the easy connection of my classic and widely favored basic humidifier. It has two fogger heads for redundancy reasons, so I added two humidity connectors. Here you can find the design for my classic humidifier. Connect the 5V output of the step-down converter to the humidity controller. Install the connector. Install the second connector. The main board is nearly finished. Install the two extra constant 12-volt plug/connectors. 10 centimeters for connector 1. And also for connector 2. Screw them in place. Great. The main controller is ready. Power it up and check if everything works fine. Make sure to cover the input cables of the 230 volts to the power supply. Check the outgoing power for the humidifier, it should be about 5V. You can also just trust the digital display. If you want to build this design even cheaper, then you can use step-down modules without a display. Then you must use a voltmeter to set them up correctly. When you close the cable canals, your board looks really clean and is ready for usage. Print out your controller mounts. Your unit needs to support this mounting type. Please check before you print it. Here you find the design for printing. Please do not use red rope. If you use black rope, it looks really great and is less noticeable. I only used red rope to demonstrate how this design functions. No need for drilling with this mount. Plug in the controller to check if everything works fine. I also installed the humidity sensor. It goes into the tent from the top. If the cable is too short, you can add 1 extra meter of cable without any problem. I always use the sensor in combination with a small fan. This fan will be connected later. It ensures that there is a constant airflow. I turn the sensor's backside to the incoming airflow. These are the timers that I use to control the duration my lamps run. For the grow tent, I use 18 hours. I currently use 2 lamps. Lamp 1, 6 hours and lamp 2, 12 hours. For the flowering tent, I use 12 hours and only lamp 2. I use this lamp before my solar modules provide power for my main lamp. During daylight hours, I get energy more cheaply because of a solar balcony system. This is my main lamp. Please do your own research and choose a great lamp that satisfies your needs. This is the hanger mount that I designed. Of course, you can also buy hangers if you prefer. To ensure proper air circulation inside the tent, I always have a fan on the floor. In combination with the top fan and maybe an active grow light that includes also a fan, there will be a supportive airflow inside. This fan is connected to a constant 12V supply, so it runs at maximum speed. This is a very simplistic design I created. Since I had the fan already installed, I needed an extra connection on the ground. I always use some zip ties so that nothing is able to touch the ground. Now I will connect the exhaust fan. Here I use the variable volt output in order to be able to change the exchanged air rate. This is an 80 mm fan. The size must be 80 mm because the exhaust hose has a diameter of 100 mm. Since these fans cannot build up much air pressure, the fan needs to be the smallest part in the exhaust system. It is sufficient if the plant is just a little bit away from the fan, it will work just fine. I place it on the ground because it can better extract the humidity from there. There is always excess humidity whenever the lamp is turned off. Feel free to use this ventilation system. I tidied up the wires a bit. Since I work in the basement, I make sure to keep all electronics off the ground. This next section is optional. It is needed if you want to use your tent as an optimal dry tent. It is also needed if you have low humidity inside your tent, in which case you will need a humidifier. If you have high humidity, you can speed up the exhaust fan to change the air exchange rate. I read online that a standard 80 mm fan can move a volume of 130.83 m superscript 3/h. The controller board also functions without this add-on. You can always add it at a later time or add standalone units. The recommended humidity levels for growing cannabis range from 30% to 70%, depending on the growth stage. Maintaining these levels promotes healthy growth and prevents mold and mildew. For drying cannabis, ideal humidity is between 50% and 60% RH to ensure slow, even drying while preserving quality and preventing mold. This humidifier is specially designed to work inside plant tents. First, install the one-channel relay module and the water pump. Just use my relay mount, or the spacer you already used. Here you will find the side mount. Now, I will add an extra WAGO connector. There is enough space inside the cable canal. Connect the relay to the 12-volt system using a 15 to 20 cm cable through the WAGO connector. Add a female 12V LED power connector to the pump and attach it to the mount to provide strain relief. This is the cable tree to connect the pump to the relay. It is connected via a male 12V LED connector, allowing you to easily disconnect the pump whenever needed. It is basically 140 cm cable with an intersection of the red power line at 15/25 cm. Please use fair ULs. This is the cable with the added male LED connector. The installation looks like this, with pictures from the side and front. Next, connect the floating switch inside the humidifier that signals the pump to start refilling the humidifier. To provide 12 volt to the sensor, I use a single 15 cm and 30 cm cable. Here is a picture of how the installation looks. Locate the connector in the lower large cable canal. Here you see the already printed and assembled humidifier, running a test before installation. It has 2 sonic discs, ensuring it will always produce mist. Now, I installed the black water hose with a straight connector at its end. It is specially designed to be used in a UV environment. You only want a little bit of water inside to prevent algae growth due to constant water exchange. The UV light should be blocked as much as possible. You can also just place it on the ground, but I decided to go with the wall mount. You can always change the cotton sticks and perform a decalcification on the sonic discs. The sonic discs of this humidifier have also proven extremely effective in my mushroom grow tent. The sonic discs are inexpensive and provide a high output. The humidifier fits nicely in a corner, and the fan will disperse the humidity inside the tent. The mount is simple yet effective. You can use this unit for a much larger tent, I just had space for this small one. The humidifier is strong enough, as long as the exhaust is not even stronger. However, if the exhaust is too strong, the air exchange might be unnecessarily high. I guess you won't find such a small yet redundant humidifier anywhere else. Since the humidifier is now inside the tent, I will start the connection process by connecting the floating switch first. The cable length depends on your setup. Now we will add an adapter for the fan and the humidifier. I use a cheap 4-line LED cable. Since it has a small wire diameter, I just fold it and use it in combination with fair ULs. The cable is 45 cm long, any wire diameter is fine. If you use LED cable, you can use DuPont connectors on the other end. Here you see the female DuPont connector crimped on the end. DuPont connectors are great, A kit for making them is very cheap and always comes in handy. Use the needed cable length for your setup and connect the cables. Put everything inside the cable tree, allowing the cables to come up from just one side. Okay, before I forget, let's connect the fan in front of the humidity and temperature sensor. The length should again be according to your system. I used DuPont connectors on the fan side and ferrules on the controller board side. It comes up from the right side because of the openings at the top in my tent setup. I just closed the cable canal. It already looks much better. Next, we will add a bit more order to our system with a cable spiral wrap. First, I wrapped all the upcoming cables up nice and neat. The upward going cables should also be wrapped. There, it looks much better. That's it from the outside. Now, only this red rope is bothering me. Of course, we also wrap up the connection of the humidifier. If you were wondering, there are even more cables inside the tent. They belong to my automatic watering system, since I know myself and sometimes I just forget to water my plants. It has helped me tremendously. I would advise using it in combination with regular watering and fertilizing, but it has been a very good safety net for me. That's it, that's the controller board. I hope your build went smoothly. Now I will show you the controller in a video. So, what do you need? Not much, and all is easy to source. Here is a list for your convenience. You need spacer. They can be found on my 3D printing page. You also need the board that we started with. I used 22 AWG equivalent to 0.5 mm square standard LED cable. This is a good tool for stripping of the insulation. You should always crimp the end of your cable before using screw connections. A set of flathead M3 screws. I just used ordinary wood screws. These are basic screws. They are universal, mainly for wood, and self-tapping. They do not mind any humidity. A set of washer. AC/DC 12V power supply, 60W transformers, 220V to 12V power supply. TZT-LM2596, voltage adjustable step-down power module plus blue LED voltmeter. The XYTR01 humidity controller features the industrial SHT20 sensor. It's a great sensor. WAGO terminals, Do not buy cheap connectors, only Wago connectors allow you to also insert ferrules. Dual row strip screw terminal block. Simple and useful clamp connector. An easy way to connect the fan and lighting to your board, if you do not want to crimp your own DuPont connectors, is to use pre-made DuPont connector cables. Wiring duct with lid cable duct length 2 meters. Spiral wrap winding protector. And of course, cable fixers. I guess everybody has them in their workshop. I use the black ones. Now the optional parts for the humidifier system. This is the pump I used. There are many 370 water pumps, this one has a mounting possibility. Female connectors for LED strip light. LED adapter power supply DC 12 volt with 5 ampere. 4-pin standard LED cable. This is a basic watering hose. The inner diameter is 4 mm. Make sure to check compatibility with your pump. That was my main video. The heart of a grow tent, the controller. Before we end, I did put a lot of work into this lecture series. I hope you enjoy it. Maybe you want to consider to buy me a coffee? There is a serious reason why I ask. In life there is balance everywhere. Summer and winter, day and night, hot and cold, and so on. It's obviously natural, that taking and giving is also a polarity that needs to be in balance. Only when there is balance can we, as humans, achieve harmony and genuine happiness. That means, if you take something for example from the internet, you should also give something back. Please check for yourself if your life is in balance. If you want, you can support me with a donation. That would be great. You could also support any other good project. Send someone a smile, leave somewhere a nice comment, or just be joyous and spread some love. What are your thoughts? Please share anything that might be useful for your fellow man. In the next lecture, we will dive into my upcoming DIY dehumidifier system. Thank you for spending your time with me. I hope you enjoyed it, and even learned something. I am looking forward to see you soon again. Happy building. Bis bald.